The cross multiplication method of solving simultaneous equations or a system of equations is probably the easiest method. You might have learnt about the substitution method, the elimination method, the graphical method, but if you come to talk about the easiest method of all, it's probably the cross multiplication method. And if you want to learn all about it in a simple and easy way, this is the video for you. Jump straight into the video. Hey guys, my name is Vikas Sharma and I welcome you all on behalf of Exponent to Success. Exponent to Success is an initiative that helps to add an exponent to your learning curve. If this is the first time that you are coming to our channel, I recommend that you click the subscribe button below and subscribe to our channel right now. Make sure that you hit the bell icon also so that you get notified each time we upload a video and so that you do not miss out on any future content from us. In our previous videos, we learnt about the graphical method of solving simultaneous equations or a system of equations. We also learnt about the table of values method, but we found that there were a few drawbacks with that. Therefore, we went ahead and learnt about the substitution method of solving simultaneous equations, and we also learnt about the elimination method of solving system of equations. Well, you could probably use any method that you want, but if you talk about the easiest method, it's the cross multiplication method. In the beginning, you might find it a little bit confusing, but this video is going to take you on a step-by-step process of how to solve simultaneous equations by the cross multiplication method, and I'm sure by the end of the video you will have no doubts whatsoever. As you know, the general form of a linear equation is ax plus by plus c is equal to 0. Where x and y are two variables, I could take any two variables here. It could be a and b, it could be p and q, it could be m and n, any two variables that you have. A is the coefficient of x, b is the coefficient of y, and c is the constant. It does not have any variable. It's a constant, and these coefficients we take along with the signs. If I talk about the coefficients here, the coefficient of x is positive a, the coefficient of y is positive b, and the constant term is positive c. But if it's an equation like this where it's ax minus by minus c is equal to 0, then the coefficient of x would be positive a, the coefficient of y would be negative b, and the constant term would be negative c. Now let us say that we have got two equations. I'll write them in the general form only, where a1x plus b1y plus c1 is equal to 0, and we have got another equation which is a2x plus b2y plus c2 is equal to 0. Here I'm assuming that both the equations have the same variables x and y, but they have different coefficients and different constants. So how to solve this pair of linear equations? Well, we learnt about the elimination method in the last video, and if you haven't seen that video as yet, just click on the top right corner of your screen and you can see the video. The first thing that we do was to take c to the other side of 0, so other side of the equal to sign. So I'll take c there. So what I get instead is I subtract both sides by c1. So what I get on the left hand side of the first equation is a1x plus b1y is equal to 0 minus c1. So let me write that as negative c1. So in the second equation also I'm going to do the same thing. I'm going to subtract c2 from both the sides. So what we are left with on the left hand side is a2x plus b2y. c2 gets cancelled, and 0 minus c2, it gives us negative c2. So these are the two equations that we have. Let me name this number 1 and let me name this number 2. Now if we want to try the elimination method, so how about eliminating y from these set of equations? To do that, the coefficients of y must be the same, but here since they are b1 and b2, there are two different coefficients. To make them same, what I can do is I can multiply equation number 1 by the coefficient of y in the second equation, which is b2, and multiply equation number 2 by the coefficient of y in the first equation, which is b1. So once I multiply these, what I am left with is a1 b2x plus b1 b2 y is equal to negative c1 b2, and the second equation becomes a2 b1 x plus b1 b2 y is equal to negative c2 b1. So those are the two equations that we get. Let us call this equation as number 3 and this equation as number 4. To eliminate, what we do is we subtract equation number 4 from equation number 3. So I'll just change the signs here because everything will change when we subtract them. And once I do that, the b1 b2 y, since they are the same terms and they're being subtracted from each other, they get cancelled out, and what I am left with is a1 b2 x minus a2 b1 x is equal to negative c1 b2 plus c2 b1. So I'll start doing it on the right side now. So if you look at these two terms that we have here, what is the common factor? If you look closely, x is the common factor, so we could probably factor out x, and what we are left inside the brackets then is a1 b2 minus a2 b1. That should give us, and here since we have got a negative sign first and then a positive sign, I'm just going to switch places for both of them so that it becomes a little easier. So it's c2 b1 minus c1 b2. That's what we get, and therefore to find the value of x, we divide both the sides by this term, which is a1 b2 minus a2 b1. So what we are left with on the left hand side is only x, and on the right hand side we get c2 b1 minus c1 b2 over a1 b2 minus a2 b1. So that's the value of x. So once we have a system of equations and we know the coefficients including their signs, then what we can do is we can just substitute or plug in those values of coefficients into this equation, and we can find the value of x. It's as simple as that. And once we have the value of x, which I have written here in the top right corner, we can try and find the value of y. And if you remember the video of the elimination method, how we used to do it was we used to find the value of one variable, plug it back into any one of the two equations, and then find the value of the other variable. So we are going to do the same here. We had the two equations as a1x plus b1y, which we had changed later to minus c1, and a2x plus b2y is equal to minus c2. So what we are going to do is we are going to plug in this value of x, this value, right into equation number 1. Let me call this equation number 1 and this as 2. So plugging in the value of x in the first equation, we get a1 times, and here the variables are a little we've got c first and then b. I'm going to change the order so that we don't have any problems. So we have got b1 c2 minus b2 c1 over a1 b2 minus a2 b1. So that's the value of x that we have put in here, and then let's write the rest of the equation, which is b1y is equal to negative c1. Now we'll multiply this a1, apply the distributive property, multiply it with both the terms here in the numerator, first this and then this. So what we get instead is a1 b1 c2 minus a1 b2 c1 over a1 b2 minus a2 b1, and the rest of the equation stays as it is, so it's plus b1y is equal to negative c1. So now, since we have to find the value of y, I'm going to take this term to the other side. So what we are left with is b1y is equal to negative c1 minus a1 b1 c2 minus a1 b2 c1 over a1 b2 minus a2 b1. So taking the LCM of both these terms, or making them equivalent fractions, the denominators have to be the same, so I'll have to multiply this whole thing by negative c1. So let me do that here. So on the left hand side I've got b1y, on the right hand side it's negative c1 multiplied by a1 b2, so it becomes negative a1 b2 c1, then negative c1 multiplied by negative a2 b1 becomes positive a2 b1 c1. Then I'm going to write the rest of these terms as it is, but I'm going to apply the negative sign to both these, so the distributive property. So we've got negative a1 b1 c2, and negative then becomes positive, so positive a1 b2 c1, and this whole thing is being divided by a1 b2 minus a2 b1. Now what do we have here? So we've got a negative a1 b2 c1, and so this one, and here we've got a positive a1 b2 c1, so these two can get cancelled out. So what I'm left with, b1y is equal to a2 b1 c1 minus a1 b1 c2 over a1 b2 minus a2 b1. Now if I look in these two terms, what I've got is b1, so I can remove the b1 from here and I can factorize it, so I'll have a b1 common and I can remove this b1 from inside. Okay, so this was a2, so a2 times c1 minus a1 times c2, and whole multiplied by b1. So b1 on the left hand side and b1 on the right hand side, they get cancelled. So what I'm left with, the value of y, we've got it is a2 c1 minus a1 c2 over a1 b2 minus a2 b1. So again, since this is the solution, let me highlight this. Solution as in this is the value of y. So we've got the value of x on top here and we've got the value of y here. So we have found out both x and y. But when I started the video, I said that this is probably the simplest of the methods to do the cross multiplication method, but what you see is a total mess. What you see is something which we don't understand at all. So what we are going to do is we are going to write these coefficients properly and then find out what happens, what to multiply with, and it becomes, we'll make it such an easy process that it will once you practice a little, it will become like a piece of cake for you. So there we have the values of x and y, and what we are going to start is the simplification process now. Try and see what these solutions means visually, and then so that we can figure out something easier. Since I told you all these values are a total mess, it is very difficult for us to remember these values or to remember these formulae. So what we are going to do is we are going to see these coefficients visually and see if we can figure out something from that, probably an easier method. Okay, so what I notice first of all from the value of x and from the value of y is that the denominators, both the denominators a1 b2 minus a2 b1, they are exactly the same. So if the denominators are the same, what I can do is I can, if I bring these numerators below the x and this numerator here below the y, what I get is 1 over a1 b2 minus a2 b1, and here also 1 over a1 b2 minus a2 b1. So that means the values of both x divided by this numerator and y divided by this numerator, they will become exactly the same. So let me write it like that x over b1 c2 minus b2 c1, that should be equal to y over a2 c1 minus a1 c2, and that both of them should be equal to 1 over the denominator that we have left out earlier, a1 b2 minus a2 b1. Okay, so let's write these coefficients properly and see what is what. So I've got the value of x, so b1 and c, b and c. So let me write b and c here. So b1, b2, c1, c2. So what they are doing is that they are multiplying b1 by c2. So we start from the top, multiply this by this, and then subtract it and multiply b2 by c1. So when you're coming down, it's a positive sign. When you're going up, it becomes negative, right? And this whole thing, okay, we'll write that later. And here it's a2 c1, so it's c1 c2 here, so let me write a1 and a2. So it's a2 c1, so that means a2 here at the bottom and c1, so these two are being multiplied together, minus a1 c2, so or I can say c2 a1, these two are being multiplied together, and when I come down it's a positive sign, when I go up it's a negative sign. And then in the last this thing we've got 1 over a1 b2, so we have got the b terms again, so let me write the b coefficients again. So we've got b1 and b2, and now we see it's 1 over a1 b2, so this a1 is being multiplied by this b2 minus a2 b1, these two together, and when we are coming down it's a positive sign, when we are going up it's a negative sign. And all these things are the first two, b and c, that is x over the product and difference of these, and this is c and a, this is y over the product of these and these, and a and b, it's 1 over a1 b2 b a2 b1. So yes, that looks somewhat easy. So just to revise, let's do it once more. on a new page. Let's not forget. So what, it's very simple. So we have to start with B's first. So it's B, C, and then A, and then back to B. So you start from B, C, then A, and then back to B. So let's go to a new page and let's see how much we remember of these. Okay, so we are back to a new page, and if we remember, we had to start with the coefficient B's. So I'll write them here: B1, B2, then we go to C, C1, C2, then we go to A, A1, A2, and then back to B. So B1, B2, and then we remembered that we have to multiply B1 by C2 minus B2 by C1, and that whole thing is being divided by X. And then we had to multiply C1 by A2 minus the product of C2 and A1, and that whole thing is being divided by Y. And then A1 multiplied by B2 and A2 multiplied by B1, and that whole thing is being divided by 1. So yes, that's easy to understand, easy to remember, and it's not much of a problem. So what we can do is we can try and use this method every time. Just take the coefficients and write them in the order B, C, A, and then back to B, and then see how we can solve the problems. So remember that all these things, X upon this is equal to 1 upon this, and so Y upon this is also equal to 1 upon this. So right, how about trying a question? So we've got these two equations: 2p plus 3q is equal to 18 and 3p minus 4q is equal to -7. I've intentionally taken up negative values also, so that in one example only we understood everything. Because we had to write the coefficients b1, b2, so we had to start from b, then proceed to c, come back to a, and then back to b. So that was how it was. So let's see what is the value of A1, B1, C1, A2, B2, C2. So from the first equation we see that A1 is 2, B1 is 3, and C1 is 18. Okay, there seems to be a problem. C1 cannot be 18, because when we started this, what we had was we had to convert this where all should be equal to 0. So what we'll have to do is we'll have to bring the C to the other side first, and then use that coefficient of C. So let's see, the first equation that we have, that becomes 2p plus 3q, and we are subtracting 18 from both the sides, so it becomes minus 18 is equal to 18 minus 18, that becomes 0. So yes, we have written this equation in the standard form, and same we'll do here. We'll add 7 to both the sides. So the second equation we have is 3p minus 4q plus 7, that should give me minus 7 plus 7, which is again 0. So these are the two equations here. I'll write the coefficients b1, b2 first. So b1 we have is 3 and b2 is -4. Then I'll write c's. So I've got -18 and 7, and then I'll write the a's. So I've got 2 and 3. Please take note that I am taking the negative signs also into consideration. And then we go back to b. So b again was 3 and -4. So let's try and find the value of x first. So we remember the first two was x over that. So on the left hand side we've got x over the product of 3 and 7. So that happens to be 21, minus the product of -4 and -18. So -4, 18 into 4 is 72, and minus into minus becomes plus or positive. So we've got 72 21 minus 72, that should equal to 1 over a1 b2. So this one was 1 over things, so 2 times negative 4 becomes negative 8, and then we had to subtract the product of these two, so 3 times 3 is 9. So that should give us the value of x. So that means x over 21 minus 72, so that is going to bring me to a negative 51 is equal to 1 over negative 17. So which means multiplying both sides by negative 51, I get x is equal to negative 51 over negative 17. The negative and negative get cancelled out, the 17 goes into 51 3 times, and I get the value of x is equal to 3. Again, let's highlight that as the solution, and then we'll try and find the value of y. So y was these two middle terms here, y over this. So we get y over the product of negative 18 and 3 is negative 54 minus the product of 7 and 2, which is 14. That should equal to 1 over, so since we have already found the value of 1 over all this, let me write it straight as 1 over negative 17. And negative 54 minus 14 becomes negative 68, and so I'm going to multiply both sides by negative 68. So what I'm left with is y is equal to negative 68 over negative 17. The negative and negative get cancelled, and 17 goes into 68 4 times, so y is equal to 4. Now this is the solution where the ordered pair x is 3 and y is 4, so the ordered pair 3 4, that should satisfy both these equations simultaneously. Now one thing that I've forgotten here or made a mistake here was that these are not the values of x and y, because the variables that we have got here are different. So this should be p is equal to 3 and q is equal to 4. So the solutions remain the same, which is the ordered pair 3 4. So let's try and plug in these values and see what we get. So when we plug in the value of x, so it becomes 2 times, so I'll plug it into the first equation first. So 2 times 3 plus 3 times y is, sorry, q is 4, so I'll write 3 times 4, that should give me 18. And let's see what do we have here. 2 times 3 is 6 and 3 times 4 is 12, so 6 plus 12 is 18. So the second equation says 3 times p, so 3 times 3 minus 4 times q or 4 times 4 should give me negative 7. And when I do 3 times 3 is 9 minus 4 times 4 is 16, that should give me negative 7. And yes, 9 minus 16 is negative 7, so that means this solution of p is also correct. So there we learned this method of cross multiplication. It was very confusing for us in the beginning, but then when we tried to see it visually, we tried and figured out if it could become a little easier, and yes, it did become a little easier. And then using that method we went ahead and solved an example problem. So we found the values of both the variables p and q. We substituted those values back into the equations and saw that it does satisfy both the equations. So that is how the cross multiplication method works. In case you have any questions, I would like to hear about it. Please leave your comments in the comment section below, because I'm waiting to hear how did you find it. I found it after the visual representation, it became very easy for me, but how do you find it? Do you still find it tough? Do you find it easy? How did this video help you? I want to know all about it, so please leave your comments in the comment section below. And also, one more thing that I would like to say is that if you like this video and if you like the other videos that we have made, you should share these videos with your friends, because you have learned a lot out of these videos, and why should they miss out on all the fun? They should also try and learn something from these great videos that we have. And please refer these videos or share these videos with your friend. And in case you still haven't subscribed to the channel, then you press the subscribe button right here and subscribe to it right now, and do not forget to press the bell notification so that you don't miss out on any of our great content. You can watch these videos on the left as your next videos, and take care. God bless.